Why, hello there, my little mathematicians. Welcome to trying to figure out the surface area of rectangular prisms. I'm going to help you get started on your homework, which is ES-1, surface area of rectangular prisms, counting squares worksheet. We're going to do number 1 together so that then you can do the rest. Okay, if you take a look at your drawing, it says counting squares because they're telling you how much makes up the area of each individual surface of your rectangular prism. So if I take a look at this shape right here, let's first of all focus on my front face, okay? The very front face has a length of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3. So when I go to find the surface area of a 3D shape, I want to find the individual area of every single side or face that makes up the shape. And so to do that, it's helpful if I think of it as unwrapping a present and drawing the net out. So I'm going to draw that front face, which is a 6 by 3. Okay. And then I also need to find this side face, which is 1, 2, 3 high and a base length of just 1 across. So I can draw that coming off right here as a 3 by 1. Okay. And then that makes up the front and back. Here's the two sides, and then you also have the top and bottom. Well, the top and bottom, it's 1, 2, 3, 4, 5, 6 across, and only 1 wide, right? So that's a 6 by 1. So I'd probably draw that one coming off right here as a 6 by 1. And as you can see, that looks almost bigger than this one. And sometimes that happens and you're like, whoa, how can this be 6 by 3 and this is 6 by 1? That looks totally unproportional. A lot of times the drawings aren't drawn to scale, so you just have to take it for granted of what it says versus what it looks like. Or if you're a perfectionist like me, you can take the time to actually redraw your figure more accurately. But at the same time, I purposely drew it a little bit bigger because I wanted to point out that you can't always take it for granted of how it looks, because you have to pay attention to what it's labeled as, because a lot of times you'll see that figure not drawn to scale sentence, and that means that even though this side looks longer than this side, you have to take for granted of what it's actually saying, okay? So, but since I'm a perfectionist and I'm drawing it myself, I'm gonna redraw this as a 6 by 1. Okay, now this only has 1, 2, 3 sides, but this figure, if I were to unfold it, it has 6 sides, right? Because the front and back are the same. So the front and back would be the same. You'd have 6 by 3 happen twice. And 6 times 3, when you multiply those areas, 6 times 3 gives you 18. So the front and back each have an area of 18. And then this top and bottom is what separates it. It doesn't matter where you draw it. I could draw like if this is the top, I could draw the bottom here, or I could draw the bottom on the top part. It doesn't matter, whatever your preference is, okay? So this is a 6 by 1 again, because if this is 6, so is this. And also like refer back to your drawing. So 6 times 1 is 6. This 6 times 1 is also 6. So I have my front and back, my top and bottom. Now I just need the two sides. Well, the two sides were the 3 by 1. So 3 times 1 is 3. And you can draw your other side right here, or sometimes like when you unfold it, it could be out here. It doesn't necessarily really matter where you draw it. It's just like if you were to imagine it unfolding in your mind, where did you unfold that particular part? Okay, so if this is 3, so is this, and here's the 1. 3 times 1 is 3. Always double check that you have all of your sides. You have the top and bottom that match. You these are the right and left sides that match. You have your top and bottom that match, and you have your front and back that match. And then you can just add all those together, or what I like to do is that you have your front and back There's 2 of those that are each 18, and 2 times 18 is 36. And I also I know it seems silly, but I like to label the front and back just as like a double check, catch myself that, okay, front and back 6 by 3. Yes, I didn't mess up. Okay, and then my sides, so my right and left, there's 2 of those that are each 3 by 1, which is 3, and 2 times 3 is 6. So if I were to add both of those together, I'd get 6. And then you also have your top and bottom. And your top and bottom, there's 2 of them that are identical. They each have an area of 6, and 2 times 6 is 12. So this represents all the 6 sides, okay? The area of all 6 of your sides. So then I just go ahead and add those all together. 6 plus 6 is 12. 12 plus 2 is 14. 1 plus 3 is 4. 4 plus 1 is 54. And then you always want to pay attention to your units. Well, if you look at your worksheet right here, it said each individual box represents 1 square inch or inches squared. So these were all in inches. Okay, and then the actual, when you're finding the area, it's inches squared. So my total surface area is 54 inches squared. And always, you're about appeasing your math teachers, right? Okay, 54 inches squared. Always box your answer in your workspace. Draw your picture out. Later on, when we get to more formulas or different shapes that have formulas involved, I'd suggest writing out the formulas. But for right now, it's pretty easy. They're all just rectangles. Okay, and this is how you do that worksheet. Okay, go ahead and finish it on your own. And good luck, my little mathematicians.